Hello, everyone. Sorry, I am late. I have had some problem in connecting. Thanks for your patience. I'm going to share my computer. Can someone confirm that you can see my screen? Let me see. All right. Where is my chart? Hello, everybody. Can someone confirm you can see my screen? Thank you, Eric. Thank you so much. All right, let me see who are here. Okay, we have a lot of people here. All right. Are there any questions? Anything? So last class, we did discriminant analysis. So basically, we want to put people into groups in discriminant analysis. The example I gave last class, remember we put people into 3 groups: individual achiever, team player, poor performer, okay? Those are based on some dependent variables. So today, we'll do another analysis, a new topic, factor analysis. So today is factor analysis. What is the factor analysis? I want to use a data file so that you have a concrete example to help you understand the concept. So this data file is lesson 36. Just want to get a sense of how your end will look like. Okay, you can see my screen. Okay. Oh, thank you. All right. So I'm going to open up my SPSS. Remember, if you're online, you can use Windows Virtual Desktop to access SPSS. Oh, where is my SPSS? Oh, it's here. I have to move my window around so that you are not. Okay, it is still loading. All right, so now I'm going to open a data file. License 36. Data file. All right. So if you look at the variable view, we have 10 variables. 10 variables. Those variables are measuring. It is a research project. I'm measuring when you how do you dealing with your emotion problems? Okay. So if I go to the meaning of those variable names, SPSS. I think 36. Okay, those are the meaning of the data set. So what does the item A? So we have 10 variables. I'm just going to copy this into my screen so that I can do analysis. Oops, not this one. Can't do it. So I'll copy screen. All right, so for example, item A, I discuss my frustrations and feelings with person at school. Item B is a statement. I try to develop step-by-step plan of action remedied by the problems. Okay, so etc. Total, we have 10 variables. 10 variables. What do we want to do? Want to reduce these 10 variables into maybe just 2 or 3 variables. So that is the factor analysis. So it is a data reduction technique. So for now, I have 10 variables. I want to reduce these 10 variables into 2 or 3 variables. If by just looking at these 10 variables, can someone have an idea if you are asked to regroup these 10 variables into 2 groups? Let's say group these 10 variables into 2 groups. And what would you do? There are 10 variables. I want to reduce to 2 variables. Okay, let's do it together. So for item A, I discuss frustrations with somebody. Item B, I try to develop step-by-step actions. So this is I. I try to do something. Item C, I express my emotions to my family and close friends. This is other people. Item D, I read, attend workshops, or sought other educational approach. So this is I want to do something. Item E, I try to emotionally honest with myself. This is I try, okay, this is a self-directed. And then item F, I sought advice from other people. So other people directed, other. Item G, I explore the emotions caused by the problem. This is I. Item H, I took direct action, but I try to correct them. This is self-directed. Item I told somebody. This is other directed. Last one, I put aside other activities so that I could work. So this is still I. So as you can see, out of 10 variables, maybe we can group those 10 variables just into 2 groups. One is self-directed. The other is other-directed. Do you agree? It looks like put into the category. There are 10 variables. I want to reduce them, okay, just in 2 variables. So this is what is the factor analysis? Okay, what is the factor analysis? And the 2 groups, okay, I'll try to start typing because it's difficult. So, try to increase the font size. So, there are 10 variables. But we try to reduce number of variables into 2 we call constructs. Means 2 categories. 2 categories. And one is self-directed. The other is other-directed. So the self-directed is a construct. Other-directed is a construct. Okay. So this is what do we do? Why we do factor analysis? Basically, it is data reduction technique. Okay, now when you do data factor analysis, there are 2 stages. 2 stages. One is factor extraction. The other is factor rotation. Factor extraction. So in factor extraction, we are going to use principal component analysis. Principal component analysis. And then we'll introduce a new terminology. Actually, it is not new. In discriminant analysis, we have eigenvalues. Okay. So that we are going to use eigenvalue again. It is just the variability of the factor. The variability of the factor is eigenvalue. So that is 2 stages. In stage 1, We use principal analysis. And then in stage 2, those stages are done behind the SPSS. We do not see it is inside the box, okay? This is the theoretical explanation. So in stage 2, we rotate the factor. And the rotated factor may be unrelated or may be related. So in this stage, it could be orthogonal. We can, so the rotated factors may be uncorrelated. When they are uncorrelated, we call orthogonal. But maybe they are related. When they're related, we call oblique. And the most popular rotation method is called VARIMAX, Varimax. So those are some terminologies. Like any analysis, we need to understand the assumptions underlying factor analysis. What are the assumptions? Assumption 1, the measured variables are linearly related to the factors plus errors. By the way, the example I am giving you, I said there are 10 variables, but we try to reduce number of variables into 2 constructs. Actually, we can also call 2 factors. Okay, there are 2 factors, self-directed and other-directed. Okay. So the measured variables are linearly related to factors. That is assumption 1. So just tell you what is the factor. In our example, we have 2 factors, self-directed and other-directed. Assumption 1 said the measured variables are linearly related to the factors plus errors. That is assumption 1. Assumption 2, chi-square test for the maximum likelihood solution assumes that the measured variables are multivariately and normally distributed. Okay, so the measured variables are multivariately normally distributed. Multivariable. So those are the so for our data set, what is our research question? In our data set, our research question. So we want to ask, is there any single okay, by the way, those are refer to the same terminology, construct, factor, or dimensions. Dimensions. They refer to the same thing, different terminology, okay? Construct, factor, dimensions. So my research question is there a single dimension or are multiple dimensions underlying the 10 variables. So in other words, can we group those 10 variables into just one group or two groups or three groups? That is my research question. Okay, so now we are going to introduce some terminology and what is the purpose of factor analysis. What is my research question based on this data set? Okay, now we are going to do two steps. Step one, conduct factor extraction. Okay. Step one, factor extraction. So make sure you have this SPSS data file ready. So try to see my online students. You are here. So any questions so far?
Professor?
Yes?
Does the BRI max stand for anything?
It is just it is a rotation method. That method is very much how that word comes from. I don't know. Maybe you can Google. Okay, where the word VARIMAX come from. Okay. Any other questions? Let me check the message. All right, so now we are going to do the factor extraction. Go to my SPSS. All right, so try to also see your chart. If you have any questions, type in your question in chat area or directly speak up. Okay. All right, so go back to data view. By the way, those numbers, the numbers in, for example, number 3, number 1, number 2, what they represent? Okay, I should explain here. So it is Likert scale, 4-point scale. So all those numbers, you're right down here. We use 4-point scale with 1 represent. You can now try this approach. And 4 represent, use this approach extensively. So you understand what is the number in the data. Each data has 10 variables. Each variable, you are going to give a rating from 1 to 4. Okay, 1 represent, I did not try this approach. 4 represent, I use this approach extensively. Okay, all right, so now let's do the data extraction. Okay, so you go to analyze. Our textbook, I'll double check, it said analyze. Yes, data dimension reduction. Okay, that is correct. analyze dimension direction. And then factor. Now select all these 10 variables by press and hold down Control, and then click the last variable. And use this button to move into the variable box. Move all 10 variables. And then click extraction. In this, under the display, see, we are using principal components. There are other methods, for example, unweighted least square, generalized least squares, maximum likelihood, principal X factoring, alpha factoring, image factoring. Okay, the popular method is the principal method, principal components. Okay. Under the display, please select screen plot. Screen plot. This screen plot is actually based on eigenvalues. Okay. And then click continue. Click OK. So now we have this this output. So the first table is communalities. Okay, so this is the extraction factors we get. Okay, it is behind the computer. The second example, the second table is important. Total variance explained. So in this table, we have 10 variables here. This as the component. And over here, you have initial eigenvalues. We hope to see the bigger eigenvalues. So we use 1 as benchmark, cut off. So only 3 components are greater than 1. Only 3 components are greater than 1. Okay. And also when you look at the extraction sum of squares, sum of squared loadings, you see the percentage of variance explained by component 1 is 30%, component 2, 18%, component 3, 18%. Okay, so roughly they contribute like 60%, 58%, the component 1, 2, 3. Okay, see, this is accumulated, 58, okay, roughly. And also you should notice this total eigenvalues. If you add all these values together, they should be equal to number of variables. This might be our final exam questions. Okay, I will miss a number here. For example, the last number I will miss 0.308. I will ask you, what is this number? You need to know. This number use 10 minus all these numbers are together. I will copy this into OneNote because this part is important. And final exam will have a lot of questions like this. I give you the output. Based on the output, I ask you questions, okay? For example, you need to know all these numbers add together. If you add them together, the result should be 10, number of variables. So if I missed one number, 0.308, you should know you use 10 minus the rest of the sum of the rest numbers, you get the number I missed. Okay. So all these numbers are together. So that is total variance explained by component. And based on this, keep in mind what is our research questions. Our research question is, how many factors, how many dimensions we can get from these 10 variables? So from here, our cutoff value should be 1, but this number is 1.009, very close to 1. It is just 1. We need above 1. So above 1, it is just 2 numbers here. So looks like we are going to extract 2 factors, 2 dimensions, or 2 constructs. And this conclusion match our initial analysis. Remember, when we analyze these variables, we say, this is other directed, other directed, other directed, other directed. And those questions are self-directed, self-directed. Looks like we have 2 categories, 2 dimensions. It is match our result. Did you get that? Okay. So we have over here, self-directed and other directed. So we get this idea based on total variance explained. And now, this is the screw plot. It is based on eigenvalue, on why it is eigenvalue. Based on, during the final exam, I will give you a plot like this, and I ask you how many factors will be extracted. And your answer should be based on how many points above 1. So this point is above 1. This is 1. This is number 1. Okay, this is 1. You count. This is 1 point above 1. This is 1 point above 1. This is 1. We don't count very close to 1. We are count above 1. So there are 2 points above 1. So 2 factors. Again, this conclusion match our initial analysis. Remember we're saying we have other directed and self-directed based on this statement. Those are our 10 variables. Okay. All right. So we get idea we have, look like we have 2 factors, but it didn't tell us which items. By looking at here, we know, looks like item A, item A, item C, item F, item I, those are other directed, okay? So item B, item B, item D, item E, item G, item H, item J are self-directed. this is by our manual analysis. We just look at the content. But how do us let the computer to tell us? Okay, item A, item C, item F, item I belong to one factor. And then, okay, item B, item D, item E, etc. belong to another factor. So this is our next stage, rotation. Is that clear? We want to let the computer give us group. Okay. So let's do second stage, stage 2. Rotation. Stage 2, rotation. All right, so go to the data again. Now we are doing stage 2, rotation. Any questions? Okay. Are we supposed to have access to your OneNote? I don't know how I would like to, but I don't know how you can access the OneNote. I don't know how you can access. If you can tell me, I would like to share my OneNote with you, but I don't know. Anyone know? Oh, I know that, but that is after fact. After that, I can save it and post it, but the real time, I don't know. Okay, yes, Jacqueline.
OneNote does have a share function. It can just be a little bit difficult to kind of organize what you're giving us access to.
Thank you. I have to explore. Okay, so this is my OneNote. It is maybe my personal Microsoft. I have many Microsoft accounts. Okay, maybe I will try to save it. You know what? You can. This lecture recording is recorded. Please check out the lecture recording if you want to refer to the OneNote. Okay. Sorry, Eric. There is a way to save it and upload it to Sakai. I know because it is a large file. I did it before. Thank you for mentioning that. I remember now. I can save it in PDF file and upload. But this lecture is being recorded. You can maybe re-watch the lecture recording. Okay, Eric? Yeah. And another way, for example, if you see my screen, you can copy screen, everybody. You copy screen so that you can save on your computer. You can print screen, right? Eric, you can print this screen to get these notes, get this image. Okay. All right, so where we are, so we are going to do step 2, factor rotation. Okay, so. Okay, stage 2, rotation. Go to analyze, dimension reduction, factor. We are still having these 10 variables. Okay. Now, quick extraction, and then typing 2 in number of factors. So we want to extract 2 factors, remember? Okay. So number of factors, click this button, 2, Y2, not 3, not 1, anyone? Why we type in 2, not 3, not 4? Yes, Rhoda.
the support regions we have based off of that graph and that against value, that we got.
Yeah, because eigenvalue greater than 1, we found 2 during our first stage. Okay, during our first stage, we found 2 factors. Okay, and then from the drop-down menu, the method select maximum likelihood. Maximum likelihood. And don't select screw plot, deselect screw plot. Click continue. After that, quick rotation. Right? Rotation here, rotation. And then we use very max method. And then click continue. After that, click descriptive, and click univariate descriptive. Univariate descriptive. Maybe okay, maybe deselect initial solutions. And then click continue. And then click OK button. Okay. All right. So we are here. Okay. And we get descriptive analysis. Remember, we have let me copy with total variance explained. So this is just descriptive statistic. Remember, we have 10 variables. What is the mean? What is the standard deviation, etc. Okay. And then we have this factor, rotated factor matrix. And based on this one, you can tell which items belong to group, belong to self-directed, which items belong to other directed, okay? Because this table is important, I am going to copy this table into my OneNote so that I can make annotation, okay? Copy screen. Eric, if you want to get the notes, you copy screen, okay? You can copy your screen. You can see my screen, okay? I did the same thing. And then paste it, Control-C. See, I pasted my screen, okay? And you paste it onto your OneNote. You can make annotation by yourself, okay? Okay, I'll try to make this bigger. And remember, we have 2 factors. One is other direct. If you look at item A, can anyone say item A belong to self-directed or other directed? Anyone? If I give 10 variables in 2 categories, one is self-directed, one is other directed, what item A belong to? Jacqueline? Other directed. Okay, great. So A is other directed. So we have other directed. And 2 represent self-directed. without looking at original table, how do you know, based on these two values, 0.778 and negative 0.116, how do you know item A belongs to factor 1 or factor 2? You do this. Assign item A, which the bigger the number, then you go that group. For example, do you agree the absolute value of 0.778 greater than 0.116? Okay, so if you agree with that, item A belongs to factor 1. Factor 1 represents other directed. This is how computer tell us. Item A belongs to self-directed or other directed. Look at the number. Yes.
How did we know that 1 was other and 2 was self?
Good question. Yeah. How do you know 1 is other? Okay. So this is original data variable, right? Okay. If you look at item A, I discuss my frustration with other people. This is other directed, we know. If you look at item B, I try to develop step-by-step plan. This is me, self-directed. Okay, so we know from original data. But here, your question is, oh, based on our knowledge about original data, we say item A, item C, item F, those are belong to other directed. You interact with other people. And item B, item D, etc., you interact with yourself. We know, okay? That's why we gave it the name other directed, self-directed. You could give other name. The name is just a label. You could say interaction with people or solve the problem by myself, those two categories. Okay? So return back, how do you know? This is a human being researcher gave label to those two categories. Does that answer your question?
Like, I know we did it from the data itself, but because it's in the labels 1 and 2, how do we know that 1 is itself and like it's other instead?
Okay.
Because I understand like.
Yeah, I understand your question totally. Yeah. So how do I know 1 represents other directed, not self-directed? Good question. Okay. Just looking at the number, 2 number here. So which number is bigger?
So I know like the bigger number you go with that one.
Yeah.
Here, but like the title itself.
The title researcher gave it. You as a researcher, you can give it the title.
So
You can just simply call, this is factor 1, this is factor 2. That's it.
So we find it from the original data?
Yeah, you found from original variable name, variable meaning. What is variable item A represent? You go here. What is item A represent? Okay, good question. Any other questions? Okay, let's do another category. Okay, we did it. Okay, let's do, how do you know item E belong to which category? Item E. Anyone? Alex, you want to try? Alex, you want to try? Where item E belong to? Factor A, factor 1 or factor B? Factor B, correct. Why?
Oh no, not outstanding.
Oh, sorry. Yeah. Adrian. Yeah. So factor item E belong to self-directed because 0.391 greater than 0.290. Okay, thank you. Sorry for calling your wrong name. Okay, so this factor matrix tell us which item belong to which group, which factor, basically. Okay. All right. Any questions? Okay. And if you look at the goodness of fit test, chi-square, the p-value greater than alpha. When p-value greater than alpha, not significant. And remember assumption 2. The assumption 2. I need to add something here. Assumption 2 mentioned the chi-square test. Okay. So chi-square test for maximum likelihood solution assumes that the variables are multivariate normally distributed. Okay. This has the chi-square test related to assumption 2. Maybe I'll type it up. So the oops. Chi-square for the maximum likelihood solution assume that the measured variance, blah, blah, blah. Okay, so I updated the assumptions. So goodness of fit, we hope it is not significant so that normal distribution are assumed. Okay. All right. Yes.
Could you go back up to the assumption?
Sure.
Thank you.
You're welcome. There are some typos, sorry. All right, so we answered this research question here. We are saying we can extract 2 factors, okay? Extract 2 factors. One factor is self-directed. The item include self-directed, item B, item D, item E, G, H, J. The other factor is other directed, include item A, C, F, and I. So any questions? Okay, shall we all take a break? Come back at 10 after 2. We'll continue with this lesson, okay? I will just stop recording. When we come back, I will start recording again. Stop recording.